Alright guys, welcome back to another edition of Math. And today we are going to talk about factoring special products. This is going to be 10.6 in your textbook. So let's get started. Here we go. So from last week we had something like this. We had x minus 2 times x plus 2. So when the first two variables here are the same, we end up with x squared, and when these two numbers are opposites, we end up with minus 4. And this is going to be the case all the time. Let's say we had m minus 6 times m plus 6. Well, same thing. This is always equal to m squared minus 36. And you could factor this, or you can multiply this to verify that we have the right answer. You can multiply m times m, that's m squared, m times 6, 6m, negative 6 times m, negative 6m, negative 6 times positive 6, negative 36. These two are like terms. They're additive inverses, so they can be canceled out, and we end up with m squared minus 36, and that's what we have up here. So this is a much faster way to reach your answer. Another example would be something like 2x minus 5 times 2x plus 5. These are the same. Multiply those two, you get, well, 2 times 2 is 4, x times x squared, negative 5 times 5, negative 25. You're able to do this. We can do this only when these two are the same and when these two here are additive inverses. If our binomials are not set up this way, then you have to distribute each one. All right? So another one that we had last week was something like this. We had x plus 2 squared. Let's do 3 here instead. Let's say I had 3 instead of 2. What this means, really, this is your base, and that's your exponent. So we have x plus 3 times x plus 3. So you can distribute the x to the x to the 3, 3 to the x, and 3 to the 3. So we end up with x squared plus 3x plus 3x plus 9. And if you notice, these two here are like terms. So we have 6x plus 9 plus x squared. Okay, so we have two of these equals 6x. So in the future, when we have something like this, let's say I have a plus b squared. All right, just like this. This is equal to a squared plus, here I had two of them, 2 of those two. So 2 of 3x, 2 of 3x, 2 of ab, plus 9. 3 times 3. In this case, it's b times b, which is b squared. All right, so this is equal to a squared plus 2ab plus b squared. This is another special product. Let's say that I had a minus b all squared. Well, a minus b squared. It's almost like a plus b squared, except this is minus. So instead of getting this right here, we get a squared minus 2 of ab plus b squared. That's the only difference. All right, so this is kind of what we did over the last few weeks. Today we're going to start with this and work backwards. So for example, let's say that I had, we're going to factor something today. Factor x squared minus 4. All right, so x squared minus 4 looks a lot like this right here. All right, and we're going to find two factors that equals to that. Well, if you notice, this is perfect. When I say perfect, that means that there's a number that you can multiply times itself twice to get that. That's x. This is a minus. This is also a perfect. And since this is a minus, I'm going to have a minus and a plus. Well, what number could I multiply times itself to get 4? The answer is 2. 2. So I have these two factors, and when I multiply these two, I end up with that. So I was able to factor out this binomial into these two. So that's one example. Another example could be something like this. Let's say I had, let's say 25x squared minus 36. All right, notice how these two, this is perfect, that's perfect. So I can do 5x times 5x is 25x squared. This is a minus, so I can do a minus and a plus. I can do 6, because 6 times 6 is 36. And so there we go. Let's do another one. Let's do 50 minus 98 m squared. We're going to factor this one. First thing you want to do is determine if we can simplify this. So is there a number that can divide 50 and 98? They're both even, so I can divide them by 2. This is going to be 25. This is going to be 49 m squared. So now what I have here is two perfect numbers here. This is perfect. And I can do 5 times 5. This over here, I can do minus 7m plus 7m. And so I have found, don't forget this too, I have found all the factors of this quadratic binomial. All the factors. All right, so let's get into the more challenging problems. And you're welcome to pause this video, go back a few times. Let's say I had 16x squared plus 24x plus 9. All right. This is going to be a special product as well. All right. So notice how this is not a 1 right now. It's not a 1. But because both of these are perfect, I know that this is going to be 4x. 4x. That's positive, so I can do plus, plus. This is also perfect, so 3 times 3 is 9. And I have my two factors. Let's do a few more. Let's say I had 25x squared minus 20n plus 4. All right, so notice how this is not a 1, but that's perfect, and this is perfect. So I can do 5x, and notice how this one here is a negative. Negative. And this is perfect, so I can do 2 times 2. And so this is my answer. These are my factors. But notice how both of them are the same. 5x minus 2, 5x minus 2. I can write this as 1. 5x minus 2 squared. And that's your final answer. All right, feel free again to go back, pause it. That was 10.7. Let's do the next one, 10.8 in your book. And really what we're going to do here is we're going to factor by using what you guys already know. We're going to factor by using the distributive property. So for example, let's say I had 3 times x plus 6. Well, what does that equal to? Distribute, you get 3x plus 18. All right, so what we're going to do is we're going to start with 3x plus 18 here, example 1, and we are going to look for a common factor in 3x and 18. So what's a number that divides both a 3 and an 18? What goes into 3 and what goes into 18? Same number. Well, 3. So you can pull out a 3 from here. That's going to be x. This is going to be 6. And you were able to factor out this binomial. So we worked backwards. We're using the distributive property, but working backwards. All right? It's called the inverse. You're going backwards. Let's do another problem just like that. Let's say I had 2x squared plus 8. All right. So what is a common number, common factor in 2x squared and 8? What divides 2 and 8? Well, 2. So 2 times x squared plus 4. We factor it out. Let's say I have a 3x squared plus, let's do 9x. Same thing here. What divides 3x squared and 9x? Well, I can divide this by 3 and by 9. And I can also pull out an x here and an x here. For example, 3 times x, or 3x times x is 3x squared plus 3. 3x times x is 3x squared. 3x times 3 is 9x. So I have these two factors. All right, so we are factoring using the distributive property. Let's do another one. Let's do one here. 4. Let's say that I had 4x squared, well, 4x to the third, plus 20x squared, plus 24x. Let me go back here. There. So looking at all these terms, what's a number that divides 4, 20, and 24? Well, what comes to mind is 4. But notice all of these have x's. I can pull out an x as well. So 4x times x squared is 4x to the third. 4x times 5x is 20x to the second. 4x times 6 is 24x. And it appears like we are done, except we are not. If you look carefully here, we can factor this out further. Since this is x squared, x times x is x squared. Think of two factors that will give you a product of 6 and a sum of 5. You can do 3 times 2 is 6. When you add these two, you get 5. Don't forget this one here. So these are all my factors. Alright guys, so this is 10.8. I will go over this in our Zoom meeting today, but nonetheless, you can go back and review this video for clarity. Okay guys, have a good day.